Hello everybody. In this video, let us discuss about some more bits related to quantum mechanics. The first question, any two variables are canonically conjugate if their operators A and B obey the relations A comma B equal to AB minus BA, which is equal to. So, any two variables are canonically conjugate if operators are AB minus BA, then this is equal to, he is asking. H cut is the answer. Next, for Hermitian operators, a Hermitian operator is a self-conjugate like a real number. So I wrote answers in the red pen, question with blue pen. Next one, if J1, J2 are angular momentums of two non-interacting systems and J represents the sum of Ji1 and J2, J equal to J1 plus J2, then the option is J1 square and Jz square commute with both J square and Jz. Okay. Now next step, the wave function associated with a material particle is finite, continuous and single valued. Next, a particle moving in a negative potential field which vanishes at infinity. The spectrum of negative eigenvalues of energy will be discrete. The wave function of particle in classically forbidden region is a negative exponential. Next, the two commutating operators can have simultaneously eigenfunctions only if they separately commute with Hamiltonian. When they have the simultaneous eigenfunctions, the two commutating operators will have simultaneous eigenfunctions only if they separately commutate with Hamiltonian. Now next, a free particle can carry any amount of energy. Okay? And so its energy is continuous. So a free particle's energy is continuous. It can carry any amount of energy. When any linear combination of eigenfunction psi star 1 comma 2, okay, is equal to A psi 1 comma 2 plus B psi 2 comma 1 also belonging to E, the system is said to be, okay, A psi 1 comma 2. Okay. Now next, B psi 2 comma 1 and also belongs to E, then the system is said to be degenerate. They belong to E, then the system is said to be degenerate. Now next, a particle has a wave function psi x comma t equal to A e to the power of I omega t cos kx. Which one is the correct? He gave the four statements. In that this statement, it is an eigenstate of energy and not momentum is the correct statement. Okay. Now next, the wave function for the motion of particle in one-dimensional box of length given by psi n equal to A sin n pi x by A, where A is the normalization, then the value of A will be under root 2 by A. Okay. The energy of the lowest level. In last videos we discussed formulas. Lowest level h square by 8ma square. Next, the spacing between the nth energy level and next level in one-dimensional potential box increases by, he said. Let us find out what he is saying. The energy level in a one-dimensional box. Okay. Generally, it is given by n square h square by 8 ma square. Right. Now, here lowest energy level, we can write n equal to 1. So, h square by 8 ma square. So, it becomes now En. This value is nothing but E1, no? So, I can write n square E1. Next in question, what he asked? The spacing between the n and the next higher level will be n plus 1. So, the same form, how can I write? N in place of n square, n plus 1 whole square, E1 minus n square, E1. So, a plus b whole square, in that form, let us do then n square plus 2n plus 1 square E1 minus n square E1. So, n square E1 cancels. So, 2n plus 1 into E1. So, this rises by the value of 2n plus 1. Okay, it rises by the value of 2n plus 1. Okay, now next, let us go for the next question. Now, next question is, if E1 is the energy of lowest state of one-dimensional potential box of length A, E2 energy of lowest state when length of box is halved. Then he gave the 4 options asking the answer. Now let us do now. So first, E1 h square by 8 ma square. The lowest is actually n square h square by 8 ma square. So h square by 8 ma square. Next, what he said? The length is halved, he said. The length of the box is halved. So length h square by 8m. So if total length a, it is halved if we think a by 2. So here a square by 4 will come into the numerator by 8m a square. Now what is this value? E1, no. So E2 equal to 4E1. Now next question. Now the energy of a particle constrained to move in a cube of side A is given by h square by 8 ma square x square plus ny square plus nz square. If nx, ny, nz may have either values of 1, 2, 3, the degree of degeneracy. Degeneracy means if quantum states are different also, the energy level will be same. The energy values will be same. Now see, 1 square plus 2 square plus 3 square. What you will get? 1 plus 4 plus 9. Okay, 5 plus 9, 14. So 14E we will get. Right answer. That is nx square plus ny square plus, here I will write. What is the formula? H square by 8 ma square, nx square plus ny square plus nz square is the formula. Now here I am substituting 1, 2, 3. What I will get? 14 of this. This is nothing but the energy. Okay. So now here, if we take these 6 combinations in this 1, 2, 3, different combinations I took? Once nx is equal to 1, ny equal to 3, nz equal to 2. Next, nx is equal to 1, ny equal to 2, nz equal to 3. nx is equal to 3, ny equal to 1, nz is equal to 2. Yet different quantum numbers you are taking. So, in these 6 sets, if we take the different quantum numbers also, the energy state will be 14E only. So, how many such we call degenerate levels. So, now here, how many combinations are there? 1, 2, 3, 4, 5, 6 combinations. These 6 combinations gives the same 14E. So, we call it as 6-fold degenerate state. Right? Now, next step, the quantum numbers of an energy state for 1, 2, 3. Here only we did know 6-fold. Now, next, if E1 is the energy of electron in lowest energy state of one-dimensional potential box of side A, E2, the energy of electron in energy state just above, means first excited state, you think no, of three-dimensional cubical box of side 2A, E1 by E2. Here we did know the same procedure. Okay. So, first, let us write E1. Generally, n square, h square, 8m square. N is 1 for lowest state. N equal to 1 for lowest state. So, 8m square you will get. Right? So, now E2. What he said? 2A. Right? That only he gave no. So, the box of side 2A he said. Then, now what we will get? For 3-dimensional, he said no. 3-dimensional, here you see lowest energy level of 1-dimensional potential box side A. Energy we got h square by 8m square, n equal to 1. Next what he said? 3-dimensional cubical box of side 2A he said. 3-dimensional law for 3D, this is 3D, this is 1D box. H square by 8m. Generally A square. So nx square plus ny square plus nz square. Right? Now next, for just sides are 2A he said. 1. Just above the lowest state means nx we will take 2. Actually 2, 1, 1 combination. You watch my part 1 video. We wrote these energy levels. ny1, nz1. Now E2 becomes h square by 8m. Here 2a whole square. Here nx is 2 square plus 1 square plus 1 square. So h square by 8m, 4a square, 2 square 4 plus 1 5, 5 plus 1 6. 2 2s are 2 3s are. Now what we got? 3 by 2 h square by 8m a square. This is E2. What he asked to find the ratio of E1 by E2. So now E1 by E2. What is E1? H square by 8m a square. What is E2? 3 by 2 h square by 8m a square. This strikes off. 2 will come into the numerator. Answer is 2 by 3. Right? 2 by 3 is the answer. Now next question. If E1 is the energy of electron in 6-fold degenerative energy state. 1, 2, 3. In a cubical potential box of side A, E2 is the energy of the particle of mass twice that of the electron in second non-degenerative energy state of side A by 2. Then E2 minus E1 he is asking to find. Right? E2 minus E1. So first, in question what he said, if E1 is the energy of electron in a 6-fold degenerative state of 1, 2, 3 cubical box of side A. Okay. First let us write E1. So E1. Cubical box of side A. So formula h square by 8m a square nx square plus, I'm taking a equal to b equal to c. Actually, what will be the formula? H square by 8m nx square by a square plus ny square by b square plus nz square by c square. No formula. But here I'm taking a cubical box. No, a equal to b equal to c v2. So, a equal to b equal to c. So, we will get a square. So, what is the formula? First, I will write the formula. Ax square by b y square by cz square. This is the formula, no? H square by 8m nx square by ax square ny square by by is nothing but a, no? Or just write a, b, c. No need of x, y, z. You will be confused. A square is the LCM. I'm writing outside. Nx square plus ny square plus nz square. Right? Now, he said E1 is a state of 1, 2, 3. Nx, ny, nz. Let us substitute, no. H square by 8ms square 1 square plus 2 square plus 3 square. 9, 10, 11, 12, 13, 14. H square by 8m a square. Right? Now, next, let us go for E2. E2 conditions, what he said. Where is the question? E2 conditions. Now, next, E2 is the energy of a particle of mass is twice. Okay? M is equal to 2m. That of electron in the second non-degenerative energy state, he said. Okay? So, now, non-degenerate means 2, 2, 2. Right? Unique set. 2, 2, 2. Now, let us do. So, this is Nx, Ny, Nz. Unique set. 2, 2, 2. Just above he is saying, the second state he is saying, so 2, 2, 2. And now, E2. The same formula. Generally, in place of M, 2m. As usual, in place of A, he said side of A by 2, he said, whole square. Nx 2 square, ny 2 square, nz square 2 square. So, h square by 8 2s are 16 m a square by 2 into 4 plus 4 plus 4, 12. 2 8s are. So, 12 h square by 8 m a square. Now, what he asked to find? E2 minus E1, no? So, what will be E2? 12, E1 14. Common will be 8 m a square. So, what we are getting? So, E2, how much we will get? Okay. E2, don't strike off this. Let it be 16. Two will come up. Somewhere we did miss. Acha, here. 2 will come up. Okay. Here we will get 12 into this 2 square 4, no. Here 2. Here I will write h square by 8 2m a square by 4 into 12. 2 2s are. This 2 will come up. 12 2s are by 8m a square h square. Right? That is 24 h square by 8m a square. So, this is 24. So 24 minus 14, 10 h square by 8 ma square is the required answer. Right? Now next, let us move to the next question. If psi 111, 111, psi 112 are the wave functions of electrons in two energy states 111, 112 respectively in cubical box of side A, then psi 111 by psi 112 value side is A, cubical box. Let us do here. Okay. Now, generally what is the formula? Psi nx ny nz under root 8 by a cube. Do you remember the formula? We discussed the formula in the part 1 video, I think. By a sin ny pi y by b a. Cubical box, no? A equal to b equal to c. Nz pi z by a. Now psi 1 1 1, let us write now. 1 1 1 means x is equal to 1, y equal to 1, z equal to 1. Sorry, nx is equal to 1, ny equal to 1, and z equal to 1. 8 by a cube. Nx 1, no. So what is remained? Sin pi x by a. Here sin pi y by a. Here sin pi z by a. Next is psi 1 1 2, no? 1 1 2. So nx 1. Let us substitute. Nx 1, so pi x by a. Ny also 1. Pi y by a. Now nz is 2. So sin 2 pi z by a. Now psi 111 by psi 112 he said to find. This only, no? Let us. Now these are common, strikes off. These are common, strike off. These are common, strike off. Now what is remained? Sin pi z by a by sin 2 pi z by a. This is the required answer. Right? Now next question. The energy of free electron in state 121 in a rectangular box of side A equal to B not equal to C. Simple only. What he said? A equal to B not equal to C. What is the energy value? Okay. What is the energy value? H square by 8m. This formula only. A equal to B equal to C said no. Nx square by A square plus Ny square by B square plus Nz square by Z square. So, H square by 8m. Did he ask to give any state? 1 to 1. What is the state? 1 to 1. 1 to 1. Nx square 1 square by A square plus Ny square 2 square by A equal to B. So A square I am writing in place of B. Plus Nz is again 1, no? 1 square by C square only. So H square by 8m. 4 plus 1, 5 by A square plus 1 by C square is the required answer. Right? Now next, let us move to this particular, what we will say the next question. The one electron, okay, one second. The one electron states of non-interacting electrons confined in a cubic box of side A are epsilon naught less than epsilon 1 less than epsilon 2 less than epsilon 3 less than epsilon 4 etc. the energy of lowest state. Right? The energy of lowest state. What you will write? Say no. E. What is the formula? N square H square by 8ma square. Right? Actually, H cut means H by 2 pi no. Okay? H by 2 pi no. Now, H will be equal to H cut 2 pi no. N square in place of H cut 2 pi whole square, 8ma square. N square, H cut square, pi square by 8ma square. So now anything to cancel? Here 2 square, 4. 4 2s are. Right? Now what we got? N square, H cut square, pi square by 2ma square. Right? 2ma square. Right? Now N square H cut square pi square by 2ma square. Now did he mention anything? Different energy levels of side A only he said. Different energy levels of side A he said. So different energy levels, lowest energy level he said. So for lowest energy level quantum numbers we take 1 1 1. So here N instead of N I'm writing. What will be the formula? This is the formula. H square by 8ma square, nx square plus ny square plus m. Directly let us here nx square, nz square. So 3 by 2, h cut square pi square by ma square. Bas. Or directly also you can substitute, no? Take the formula instead of doing all these headaches. Okay? H square by 8ma square. Right? 1 square plus 1 square plus 1 square. 3 in place of h cut is equal to h by 2 pi, no? In place of h cut 2 pi whole square by 8 ma square. Right? So 3 into h cut square into 2 2s are 4 pi square by 8 ma square. 4 2s are. So same answer we will take. Right? So 3 by 2 h cut square pi square ma square. Okay? Now next, in the above equation, degeneracy 6. Okay? In above equation, the degeneracy is not 6. 1 1 1 the lowest ground level we took, no? For level E3 he said as usual 6. 3 1 1 one state. 1 3 1 other state. 1 1 3 other state. So we are getting threefold degeneracy. If we include spin will be either upwards or downwards. Only 2 no. So 2 into 3. We will get answer 6. Okay. Now next question. Which of the following is a valid normalized wave function for a particle in one-dimensional infinite potential well? Okay. Of width L centered at x is equal to 0. Answer is 2 by L under root cos n pi x by L for odd n. Remember. Next, a free particle with energy E whose wave function is a plane wave with a wavelength lambda enters a region of constant potential V greater than 0. A free particle with energy E whose wave function is a plane wave with wavelength lambda enters a region of constant potential V greater than 0 where wavelength is 2 lambda, then the ratio of V by E. Let us find out now. Right? First, okay. So initially propagation vector formula, propagation vector we will call now. Right? If E is the kinetic energy, then lambda is de Broglie wavelength, h by 2me. Okay? Now next, this is equal to 2 pi, this comes into the numerator, by h. Now k square is equal to 4 pi square 2me by h square. H cut is equal to h by 2 pi. So h cut square is equal to h square by 4 pi square. But here 4 pi square by h square is this. So this is nothing but 2me by h cut square itself only, no? Now if I write this, how can I write 2me by h cut square by 4 pi square? I can write, no? This is nothing but h cut square. Okay? One complete. Now next, this is propagation vector versus energy. Now energy versus momentum. Lambda is equal to h by mv. That is h by p. Now same lambda is equal to h by this one. Root 2me. H cancels. So p equal to root 2me. So p square equal to 2me. E equal to p square by 2m. Okay. Now next, but p equal to h by lambda, no. From the formula lambda is equal to h by p, p equal to h by lambda. Put here E equal to h by lambda whole square by 2m. That is equal to h square by 2m lambda square we got. Now again, for the region of V greater than 0, wavelength is 2 lambda. Right? Now, let us write for this condition, the E value, or can I write for this, we will write E minus V is equal to, now the same formula but in place of lambda, I am writing 2 lambda, 2m, 2 lambda square is there. But what is the value of E? Here we find it, no. H square by 2m lambda square is equal to minus V is equal to h square by 2m 2 lambda whole square, or V is equal to h square by 2m lambda square minus h square by 2m 2 lambda whole square. If we simplify, we get 3 by 4 h square by 2m lambda square. That is equal to 3 by 4 E. Here V is there. So V by E is 3 by 4. So V by E is 3 by 4. Now next, the degeneracy of n equal to 2 level for a 3-dimensional isotopic oscillator is 6. Formula is 1 by 2 n plus 1 n plus 2. 1 by 2 2 plus 1 2 plus 2. So we will get 6. Alright. Now next, here see, a particle, he gave this diagram. A particle is incident with a constant energy E on one-dimensional potential barrier. Right? Now, the wave functions in region 1 and region 2. Region 1, it is moving in a forward direction, right? So this is oscillator. Here it became straight line up to here. It increased and it became straight line. So it is decaying. 4 options he gave. In that, oscillatory decaying matches this question. Now next, the 26th one. The parities of wave function. For cos kx, it is even. For tan hx, it is odd. Next, the commutator. Lz, ylm theta pi, where Lz is the z component of the orbital angular momentum and ylm theta comma pi is spherical harmonic is m h cut. A system in a normalized state, this we call Dirac-Ket, equal to C1 Dirac-Ket alpha 1 plus C2 Dirac-Ket of alpha 2, where Dirac-Ket of alpha 1 and alpha 2 represent two different eigenstates of the system, required that the constants C1 and C2 must satisfy the condition C1 square plus C2 square equal to 1. Now remember these formulas. A one-dimensional harmonic oscillator carrying a charge minus q placed in uniform electric field E along positive x direction. Then Hamiltonian operator minus h cut square by 2m d square by dx square plus half kx square minus qex. Next, a free particle is moving in positive x direction with a linear momentum p. The wave function of particle normalized in a length L is 1 by root L e to the power of I p by h cut x. Now next, a particle of mass m represented by psi of x is equal to a e to the power of I kx, where k wave vector, a constant, then the magnitude of probability current density is a square h cut k by m. Okay, a square h cut k by m. Now the next question. Okay, the commutator Lx comma y. Okay, Lx comma y, where Lx is the x component of angular momentum operator, y is the component of position operator. Then the value of this, let us do. So Lx comma y. Okay, the formula for this is ypz minus zpy comma y. That we can write it as ypz comma y minus zpy comma y. So this value will be equal to 0 minus z py comma y minus z comma y py. Since first bracket does not contain any conjugate pair, it vanishes. So minus z, we get the value of this will be minus I h. So that is a minus minus plus I h cut z. Now next, in a hydrogenic states, okay, in a hydrogenic states, the probability of finding an electron at r equal to 0, non-zero in state pi 1s r. According to quantum mechanics, for free particle, energy levels are continuous. A particle of energy E is incident on potential step of infinite width and height V0. According to the quantum mechanics, if E is greater than V0, then the reflectivity and transmittance of particle will be finite. Now the next question, alright, a particle of energy E is incident on potential step of infinite width. Then if height is V naught and if E is less than or equal to V naught, then R value will be 0.16, T transmittance will be 0.84. According to the quantum mechanics, the energy levels of particle executing one-dimensional simple harmonic motion is discrete but equispaced. The energy eigenvalues of simple harmonic oscillator are discrete and equispaced. Now the next question. According to the quantum mechanics, the most probable distance of electron from the nucleus in one's state of hydrogen is A0. Since the electron has intrinsic magnetic dipole moment due to spin, the electron interacts with external magnetic field and operator of momentum mu. The value must be E h cut by 2m sigma. Pauli matrices. If we neglect the coupling between electrons, orbital angular momentum and spin, then we can separate the position and spin variables. Now consider two hypothetical shells centered on nucleus of hydrogen atom with radii r and r plus dr. Okay, centered nucleus. One nucleus radius r, other is r plus dr. Then the maximum probability B of r that the electron will lie between these shells will be, assuming psi equal to 1 by root pi a naught cube e to the power of minus r by a naught cos omega t. Okay, the answer will be a naught. Now next, the degree of degeneracy of energy level 38 h square by 8 ms square with potential box of side A in cubical box is 9. In the first excited state, Triboulet generator of a particle in an infinitely deep well inside a cube of dimension L with energy 6 pi square h square by 2 ml square, which of the following is not degenerate, he asked. In that, this is not degenerate. Under root 8 by L cube, sine 2 pi x by L, sine 2 pi y by L, sine pi z by L. Note it's a degenerate. Now next. In quantum mechanics, the probability of finding an oscillator between x and x plus dx, 1 by pi under root a square minus x square. Some values of a plus is 1, commutators. A plus a, comma a is minus a plus a, comma a plus is a plus. Now, here, the eigenfunction of linear harmonic oscillator given below corresponds to the energy he is asking. Okay. So he gave this graph. The eigenfunction of linear harmonic oscillator we have to find. Okay. So for that, what is the for linear harmonic oscillator? The energy is E equal to n plus half h cut omega. Alright. For ground state, n equal to 0. Half h cut omega. 3 peaks are there. 1, 2, 3. Right? 1, 2, 3. 3 peaks are there. So now formula becomes n. For 3 peaks, n value will be 2. 2 plus 1 by 2 h cut omega. This is 5 by 2 h cut omega is the answer. Now for quantum mechanical system, every dynamical observable is represented by linear and Hermitian operator. For n equal to 3, the degenerate eigenfunction of hydrogen are n square. That is 3 square is equal to 9. Now next, according to the quantum mechanics, For the particle moving in box, the energy levels are discrete but not equispaced. The potential field of hydrogen atom, V of R equal to minus A by R. Right? Now next. The energy eigenvalues of hydrogen atom are proportional to minus 1 by n square. A spherical symmetrical potential leads to the atomic states which are degenerate with a degeneracy 2L plus 1, where L is the angular momentum. Now next, the unnormalized spin wave function of particle of spin half is given by P equal to 2 by phi up spin Dirac plus 1 by root phi down spin Dirac, where these are normalized eigenstates of Sz with Z component of spin. In a measurement of Sz, the probability of finding the value, we get 36 by 100. Right? Here, what he said, the probability of finding the value, one is, it becomes 4 by 25 plus 1 by 5. So we will get 9 by 25. 9 into 4 by 25 into 4, if we do 36 by 100, we will get. Right? Which of the following wave functions are acceptable in quantum mechanics? L minus Lz equal to minus h cut L minus. 4 options he gave, 3 are wrong, 1 is correct. The one electron states for non-interacting electron confined in a cubic box of side A are epsilon naught less than epsilon naught. This already we did. Just follow that, we will get 11 h cut square pi square by 2 ma square. Which question means this already we did. Means the same model. This one, 21st question. Follow this model. I explained. Alright. Next. In above question, degeneracy for second level, including spin, 2 into 3, 6. This also we did. 2 into 3, 6. Now, for J1 equal to 3 by 2, J2 5 by 2, total number of eigenstates 24. Right? J1 and J2. Total number is 24. Now the next question. The probabilities of transmission through potential barrier of height V0, width A for a particle of energy E less than V0 decreases exponentially with the width A of the barrier. The acceptable wave function psi must fulfill the requirement that the psi conditions, single valued, finite, continuous, normalizable, and integral of psi square dz over the whole space must be unique. The particle is confined 3D box, which are of the following belong to degenerate state. For 3 options he gave, in that E1, 0, 1, 0, 1, 1 are correct. Now next, electrons have half integral spin and they obey Fermi-Dirac statistics. The state of 2 electrons with S equal to 1, Ms equal to 1 is alpha 1, alpha 2. The state of 2 electrons with S equal to 1, Ms is equal to minus 1 is beta 1, beta of 2. Now next, the function 1 by root 2 alpha 1 beta 2 minus alpha 2 beta 1 represent S equal to 0, Ms equal to 0. The function alpha 1 beta 2 represents the state in which eigenfunction of total spin operator is not established. What are the values of sigma x, sigma y? 2i, sigma z. What is the addition value of 2 spins S1 and S2? 0. Now what is the addition of orbital angular momentum and 2 spins? 0. The state corresponding to antisymmetric value functions are called singlet state. So now, by this, we completed quantum mechanics. Stay with my channel to receive the other chapters also. Already, if you go to my playlist and search for the PG physics, you will get the first chapter, mathematical physics. And I also uploaded atomic physics and molecular physics and also thermodynamics. Now, I completed this quantum mechanics, and next chapter I will start in my next video. Stay with my channel. So write down the notes, pause the video, write down the notes, practice the bits well. Thank you for watching. Yours Reshma Physics.